Hello viewers, Assalamu alaikum. Welcome to my channel. Let's talk about some ASA high availability active failover configuration with NAT and PAT enabled in this lab. It will be a very simple lab, but inshallah we'll test that failover and we'll learn together a lot. Okay, with no further ado, let's move on to the lab. As you can see in this lab, we have a very simple straightforward architecture with one ISP. We have two ASAs here, two layer 3 switches and two Windows 10 PC, two layer 2 switches. And this lab is already pre-configured. I'm not going to configure again, but I'm going to show the prop and I'm going to discuss that prop, all the commands. As you know that ASA high availability active is a multi-context based mechanism. That means each ASA has two virtual ASA. So that 2 means there is 4 virtual ASA, and each ASA we have 2 security context. Security context is nothing but splitting a physical firewall into 2 virtual or multiple virtual firewalls. We will discuss it when we configure the failover, but I'm just giving an overview. Our goal is to go to the internet from both context A and context B, and we will test it by shutting down one of the boxes, physical boxes. Like it could be ASA 1 and ASA 2. And we'll make sure still both context from both sides can hit up to the internet. We'll test that in the browser. But as I mentioned, this lab is already pre-configured. So if I open up one of the Windows 10, okay, as you can see, this is Windows 10 CTXA having the IP address 10.34. It has the internet reachability. If I go to any of my browser, if I type YouTube, you guys can see that I have the internet reachability, and the network adapter setting in this computer is 10.1.10.34, which is this one, /29 mask, that is 255.255.255.248. The default gateway will be the switch E0/1 10.1.10.33, and for the DNS resolution I have used my physical router's DNS resolution. This is the IP address of my physical router, which is Netgear. My LAN router, which is this one, the internet. This is nothing but the bridge VMnet 0 or management cloud, this one, network. So this is the bridge network that brings up VMnet 0 or management cloud or internet. So this is the setting, and I have literally enabled the ICMP in the computer. And how I have done it, I can say firewall.cpl, and then the firewall is on, but what I did is advanced setting and then inbound rules, new rules, custom, next, all programs, ICMP v4, next, and then any IP address. Which local IP address does this rules apply? For now I'm applying to all IP addresses. I mean that rules, what I'm telling, that rules apply for all these IP address. And then next, and then allow the connection, domain private public, next, you can name it like maybe ICMP, and then you have to finish. That's all. The ICMP could reply will be allowed. That's all. So you don't have to turn off your firewall, because turning off firewall is a dangerous decision that can bring a lot of detrimental effect on your network. The same policy I applied for this computer CTXB Windows 10. This is the other computer just log on, and I'm simply going to go to Chrome, and maybe I will type Twitter. You see I have the reachability. I will go to command line. I will type ncpa.cpl. This is the network setting I have at this moment. Properties IPv4, and I have here 15.1.15.34, which is this block, and then it's a /29 mask, which is this one, and the IP block is 32 to 39. Here also the IP block is 32 to 39. 8 total host, 6 usable. If you notice, I am using the same DNS resolution. Remember, we have one ISP, so the DNS resolution will be the same, 192.168.1.1, which is my physical LAN's IP address and the gateway for this entire topology. Moving forward, now we'll test this computer. All right, so let's ping 192.168.1.1. I have the ping reachability from this computer, CTXB. Both context can reach to the internet, and I said earlier that was the goal. But one thing you need to know, you cannot ping the firewall's outside interface. I guess that is the by default policy. You have to allow that. Anyway, we are not going to dig details into that. This lab is not for allowing access. This is just a small lab showing how the failover active-active works and what is the mechanism behind it. If you ping everywhere, you can ping except the outside interface. You cannot ping 192.168.1.11, but you can ping, the gateway, the ISP. Let's fire up all the consoles. By the way, the version of this firewall is 9.1.5. It's not a virtual firewall, it's a physical firewall. Means you cannot use the V version. It has to be a physical firewall's image, not the virtual one. Anyway, ASA1, ASA2, core switch 1 and core switch B. So let's fire up the core switch 1 first. Enable show IP interface brief 10.1.10.11, which is this interface, 10.1.10.33, which is this interface. Pretty simple. All ports are up. Sim apply here. Show IP interface brief 15.1.15.11, which is this port 15.1.15.11, and then 15.1.15.33. Remember, it is /29 mask. So I can ping 192.168.1.1. Of course I can ping, but I'm just testing. Both devices has the reachability to the ISP. Remember, I told you cannot ping the outside interface 1.101. You see, by default firewall will not allow that, but you can ping the inside interface. Let me tell you very briefly about the active-active concept behind it. You see, the Ethernet 2 in both boxes are dedicated for the outside network, and we are using a shared interface. As you can see, ETH2 will be shared interface. They are going to share their MAC address so it's going to look like one interface. How can I tell this? Because if you notice, in both ASA, I'm using the same IP block, 192.168.101, and the standby unit will be 102 here in this box. In ASA2, also I'm using 192.168.1.201 is the primary one, and a standby unit will be 202. Yes, you can use the same interface, but you have to share your MAC address so that it looks like one. But for inside, they have individual security context. Inside CTXA, which is context A, they have Ethernet 1 for inside network dedicated for this traffic, and for inside B is for this site traffic, context B. But that doesn't mean they cannot forward the traffic to the ISP. Yes, they can, only when the physical box is down. It could be software failure, hardware failure, link failure. Only that time, one firewall will be responsible for both context. Whoever will be failure, the other one will be active for all roles, all failover groups, all context, and he will be the primary. And since there is preemption here, if that other box is replaced or come back again with the same configuration, then with the preemption, it will come back to its previous role. So per se, if ASA1 was primary, it will be primary, and if ASA2 was secondary, then ASA2 will be secondary. We'll go back to the secondary role. Remember, it's a multi-context based mechanism. Couple of things for the failover configuration: the interface allocation and the hardware configuration has to be the same. If you notice here in this lab, we are using Ethernet 2 as a shared interface in both ASA. Now, if you're using interface 2 in ASA 1, make sure you use the same interface Ethernet 2 for outside as well on the secondary unit. Whatever failover interface and a stateful interface you're using, make sure you use the identical interface in the primary and the secondary unit. That means ETH5 and ETH4 in primary unit, also in the secondary unit in ASA2, ETH5 and ETH4. We are using Ethernet 1 and 3 for inside traffic in ASA1. Same will be followed on the secondary unit in ASA2. 1 and 3 for inside traffic, and of course the physical device has to be identical. And you see these two switches here, they do not have any roles, they are just passing the traffic. I even didn't change the name and nothing else, so don't even think about it. Nothing else is here. All right, so now it's the time to test, right? So I will turn off the ASA2 first. Connection is still on for context A, which is this side. Let's go back to Windows 10 context B. This is context B. If you see, the connection is still on. I can still go back to the internet. I can ping the gateway, which is good. I'm already in the Twitter. Let's go to Cisco maybe. Yep, I'm on the Cisco page. So I have the reachability. Now if I test it, ASA1, enable show failover state. You see, this firewall is now active for both group, active in group 1, active in group 2. The other host, which is the secondary one, this one, it says failed. That means it's down. Okay, let's see what happens if I bring it back. Did I get any message? Okay, sending MET. We are just waiting. This message is very important. Beginning configuration replication, sending to MET. So they are communicating each other now. Now let's see the magic. Group 2 should be standby here. Yeah, I was worried a little bit what is happening, but I saw this message right now. Group 2 preempt MET. That means preemption MET. There you go. I was looking for this one. Group 2 active, group 1 active in this box here, and group 2 is a standby because that is the preemption. And on the other host, which is in this one, in ASA 2, group 1 is a standby and group 2 is active. To test that, here you go. Group 1 is a standby and group 2 is active. Alright. So this is working and I need to test this one right now. If I make it a stop, suppose, just assume there is an SPF, single point of failure. Could be hardware, again software, link failure, doesn't matter. All you care is the failure. Box is not there. Anyway, let's test this again. Ping. Still I can ping the gateway. It's in CTXA, which is context A. This computer. I'm quite sure Amazon maybe. Yep, I can go to the Amazon. Page is loading. Of course I can ping the gateway, the ISP. Seems good. Bring it back. I think after 2 minutes, 120. Okay, so preemption is enabled 122nd. That means 2 minutes. After 2 minutes, the status should change. Let's do check one more thing. Enable. Ping 192.168.1.1. Now repeat. 10,000 maybe. Okay, let's stop this now. See how many packets dropped. You see the dropping amount? It's so tiny. Control Shift 6. So my total packet drop was like this. Amazing, amazingly fast. It depends on the, in your capacity of your lab, your configuration, hardware and stuff like that. But the loss is very limited, very, very limited. Anyway, let's move forward to the configuration. We are going to solve this lab in 6. Well, let's forget about the step 6 because I already showed you the network adapter configuration. So we'll solve this lab in 5 simple steps. So the first step is going to be ASA configuration, security context, failover groups, interface, nameif configuration. Moving forward, initial configuration, config T, which is bring it to the privilege mode. Host name ASA1, not mandatory, up to you. Show mode, this is important. Firewall must run in multi-mode. If I show you here, show mode, see security context mode, multiple. By default, the firewall runs in single mode, a physical firewall. Now it's running in virtual mode. Okay, MAC address auto. That means what I'm saying that, hey, you guys need to share this interface and behave like one interface by sharing the MAC address. When you share MAC address, that means the third device is thinking this is one interface. Okay, step 1.1 is done. Step 1.2, creating context A and context B. So there's many more video for security context, and that's going to be very lengthy if I start to talk about context-based firewall. But simply to remember in one word, security context means virtual firewall, enable virtualization, making a firewall behave like two. Okay, so each security context is different. It's in a different VRF, virtual routing forwarding system, virtual routing and forwarding. They have different routing table. So ASA1, I'm saying context CTXA. I'm telling create a context by the name CTXA, config-url flash clone / ctxa.cfz. That is the storage file. Allocate interface E2 outside. This command is going to be common for both context A and context B. By saying this, I'm telling both ASA that from both context CTXA and CTXB, we'll forward the traffic to the outside network by the shared interface E2 only. That means you're going to share this interface simply. Allocate interface E1 inside A, exit. I'm saying, hey, use this interface 1 for this inside A. This is inside A, this is inside B. Use that for context A. Moving forward to the context CTXB, same commands, config-url flash, this is the storage. Allocate E2, this is common, same commands. allocate interface E3 for inside. Use your Ethernet 3 interface for inside B network. There's two inside. Not necessarily it has to be inside B. You can name it DMZ, you can put whatever you want. That would be considered as another inside. Alright, after we do this, we can check by saying show run context. We have to go to the main context and change to system. And now we can say show run context. You see? Allocate interface, same command, same thing. This is how we verify. If you say no context CTXA, the configuration will be deleted. Well, now configuring the failover active. Now this is required in both primary unit and secondary unit. That means in ASA1 and ASA2. I'm configuring on the ASA1 first. Saying failover LAN unit primary. I'm saying the physical box that, hey, you are the primary. Failover LAN interface failover. This orange failover is just a name. The same way we do nameif for inside and outside. It's like that. It's the name of the interface, nothing else. You can name whatever you want. Failover interface IP failover. You have to call that interface and then 20.20.20.1, which is exactly this one. It is a /30 mask. It has 4 IP block, 2 is usable. So I'm using that 2, 1 and 2. 0 will be the network ID and 3 will be the broadcast, so we cannot use that. So I'm telling 20.1 is your primary and then standby will be 20.2. Failover link stateful. By the way, we are configuring a stateful configuration. Stateful means if I say show failover, it has that much of information, a lot of information. Route session, route, syscommand, general, source MAC, destination MAC, etc. etc. It is not necessary, but it is the most recommended one. And then same way, failover interface IP. Stateful is just a name, nothing else. You can name it in your convenient way, but I named it stateful. 20.20.20.5, it's a different IP block, still /30 mask. This time the IP block is 427. Again, 4 total host, 2 is usable. So this side has 20.5 and the standby unit has 20.6. Prompt hostname context state priority. This is optional to see what ASA, what context you are currently in. If you don't want that, you can go back to prompt hostname. What I mean by this, if you notice it's saying I'm in context A and I'm in the primary unit, and inside the primary unit, CTX A has the active role. Primary means primary unit here. Active means CTX A is active. That's all. If you do not give this, it will be simply saying firewall. Alright, and then we have to make sure all interfaces are up. That means these two interfaces are up. 4503. There should be 4 here. And then we have to make sure these interfaces are up. You cannot ping the failable links or a stateful link being in a context. You have to exit out of the context. You have to go to the main context. You change to system, and then you can ping the stateful or the failover interfaces. Ping 20.20.20.1, 20.2, which is this interface. Also you can ping 20.5 and 20.6. Again, this is mandatory and must. If you cannot ping this, then 100% alert. You need to configure this. You need to do troubleshoot. Do whatever you need to do, but make sure ports are up and reachable. Alright. 1.4, configuring failover groups. Remember, I told you there should be 2 failover groups. So there is failover group 1 and failover group 2, and each context can join one group at a time. Make it simple. One group has one context. So group 1 has context A, group 2 has context B. That's all. But I'm saying to ASA1, failover group 1, primary, preempt 120. It's second. That means I'm telling the ASA1 that, hey, you are the owner of the group 1, and inside the group 1, context A is the primary. So here you go. You are responsible for group 1 and he is responsible for group 2. So if any of the box fail, the other box will be responsible for both groups. He is primary in both groups. And if the broken box or the failed box come back after 2 minutes, it is going to get back to their own position again. Alright, so now 1.5, associating the failover. It's the same thing that I told here. I'm telling, hey, I'm saying to join the context A in failover group 1 and telling context B to join the failover group 2. How can we check this? We can say show failover group. I'm in the primary box, show failover and then group. If you see here, show failover group 1, this host is primary, other host is secondary, and this is a stateful logical update statistics. Again, this is the state table. If I initiate the same command here, show failover group 2, this host is secondary, state active, other host is primary. Okay, now configuring the interfaces like nameif. So in context A, it has shared interface, E2 again sharing their interface, and E1 for context A this side, and E3 is for context B this side. Remember, they are in different VRF. Now guys, if you have any question for VRF, that's a different lab. Simply virtual routing and forwarding. Different VRF means in different routing table. So getting back to our context configuration, we must tell change to context A. Remember, you cannot deploy this configuration inside the system context, the main context. You have to deploy this in the newly created context. So I'm configuring the context A first, change to context A, show interface IP brief to see what is, inside, to see the status. We can do that. Change to context CTXA, show interface IP brief. This is already configured, so this is the configuration. Port is up. The only thing we are going to focus in this command is this one, IP add 192.168.1.101, and we need a standby one. This is mandatory for active configuration. One has to be standby. If the primary goes down, secondary will be active. Same for interface inside A, name if inside A, description inside A. That's up to you. If you don't want to give any description, don't give it, but I just do it. Security level 100 by default for inside A, security level 0 by default for outside A, but you can tune it. You can make it 100, 80, 70. It's up to you. Same mechanism applies here. One has to be a standby unit. I'm going to share this document with you guys. Same way, if you don't want this, if you want to make it default, just you have to say default namif, and then you have to recall that interface. Say default interface inside or outside. It will be removed. Now remember, after you configure this, you must test your ping reachability, but we have already tested this. We don't need to waste our time. It's pingable, definitely. Otherwise, we could not have been reached the internet. Okay, so ASA 1 is done. That means step 1 is done. Let's go back to step 2. And in step 2, as you can see, there's very minimal configuration. We just have to repeat the failover configuration one more time. We just need to tell this box that you are the secondary one. That's all. And optionally, you can enable monitor interface configuration. It's nothing but to say these firewalls that, hey, you guys need to watch out your interfaces. The secondary unit ASA2 must run in multiple mode. Likewise, the primary unit in ASA1. Same MAC address auto, and then literally it is very identical. There's nothing to explain again here. The only thing needs to be changed in this box. I need to tell this firewall, hey, you are the secondary. That's what I'm doing. Failable LAN unit secondary. Everything else is the same, so there's nothing to explain here. And as I said, I'm going to share this document with you guys so you can see this explanation. You can check the same way, show run failover or show failover state. It's the same. We have already checked that in the primary unit. Now, after this is done, now say failover in ASA1 and ASA2. If you do not say failover, the failover is not happening. Now it is going to replicate all the configuration between these two devices. If you want to stop the failover for any reason, you say no failover in both ASA. To enable, say failover again in both ASs. Now here is one thing very important. After you say failover, once the replication has been done, then you have to deploy any new configuration in the primary unit. I'm sorry, my EVNG lab has shut down for some unknown error, so I have to complete this video with this document. Remember, in this lab, in ASA1, context A is primary. In ASA2, context B is primary. Simple. To deploy any configuration in context A, you have to deploy in the primary unit in the ASA2. If you want to deploy something in the context B, just go ahead and deploy that in the context B. After you say failover, before you say failover, before the replication happens, you everything deploy in the primary unit. I hope this is clear. If you have any questions, please leave a comment. Exactly the same thing I'm saying here. And here am I giving an example. I'm enabling the monitor interface. If you notice here in ASA1, change to context CTXA, and I'm enabling the monitor interface. For context A, his outside interface is E2. For context A, his inside interface is ETH1. I will say monitor interface inside A, monitor interface outside. That's all. If I say show monitor, I will say this. If you notice here, it says interface outside 192.168.1.11 normal monitored. Remember, it cannot be down. Always has to be up. If there is down, then something wrong. Do the necessary troubleshoot. Also, if you enable any management interface, the management interface should show up here. This is ASA1, ASA2. All the interfaces are monitored. So I have already deployed that in ASA1. Now I am going to ASA2. Reason why? Because I said failover and the replication is already been done. So for any new configuration in context B, I am deploying that inside ASA2. Change to context CTXB, monitor interface inside B, which is this side. Hey, you need to monitor your inside interface, which is A3, and your outside interface, which is shared Ethernet 2. That's all. And here is some ping test verification from ASA 1 context A. You can ping 101 and the standby unit 102 and the ISP 192.168.1.1. Also you can ping this 201 and 202 because they are shared interface. You can ping everything on that side. The same thing I'm telling here. Same applied for ASA 2. They can ping ASA 1's 101 and 102 and the ISP. Step number 3, in ASA 1, we are going to configure NAT, PAT, access list, access group, and policy map update. So first we are going to configure the NAT. Actually this is dynamic PAT because we are using a port to translate the inside network. So it is dynamic PAT because we know for PAT we use interface, PAT, port address translation, and the whole thing is happening dynamically, as you see, dynamic interface. So it's dynamic PAT. By default, the ASA always does the translation for its inside network to the outside network. So we are saying the ASA that yes, keep your default behavior, but do it dynamically. Change to context A because we are in ASA 1. Subnet network NAT, we have to write an object network NAT. NAT is nothing but a name. We are writing an object group because there is a lot of network inside. Anytime there's more than one network, we have to write an object network. Subnet 0.0.0.0, 0.0.0.0. The first 4 octet is for network, the last 4 octet for subnets. So we're saying all the network. NAT inside a parenthesis, inside A, which is this one, inside A, ETH1, outside, which is this one, ETH2. Do it dynamically. What I'm saying, do the network address translation dynamically for the inside network with the outside interface. How can we verify NAT? We can say show run NAT, show xlet. It's the same thing. If you do not like this NAT, or if you need to remove this NAT, we can say clear configuration NAT or clear xlet. If you say clear xlet, simply it will clear the screen, and whatever NAT is translating, we can verify that saying show NAT translation. My EVNG has shut down for some unknown errors. I really do apologize for that, but I have to go along with this document. There's no way I can verify right now, but we have tested that. The lab was up and running. Alright, moving forward, anytime there will be a NAT or PAT, there should be access list and access group. Without access list and access group, NAT is not going to be effective. Again, we have to deploy that inside the context A, and we have to say access list NAT. We are just recalling the object group that we have written before. We are permitting IP from any source to any destination. The reason I'm saying extended because we know that standard is from 1 to 99. Anything other than that is extended access list. We are permitting IP. When we permit IP, IP means a lot of service with it. It's just not the ICMP echo reply. Remember, if there is any access list, there must be access group. Access group is nothing but to say the ASA where this rule is applicable. So this rule is applicable for the outside interface. That's what I'm saying here. Access NAT for inside direction, apply that to interface outside. How would I verify? We can say show run access list to verify the access list. If you want to verify the access group, say show run access group. If you do not like it, you say clear configuration access list. If you do not like the access group or you want to delete it, clear configure access group, and nevertheless modify the current policy map. Why we are doing this? We have to say inspect ICMP to allow the ICMP. Change to context A, policy map global policy, class inspection default, inspect ICMP, and then you can say write. If you want to verify the policy map, you can say show run policy map, and it's done. Literally, we are going to say the same thing inside context B. Instead of context A here will be context B. That's all. And this is step 4. NAT, PAT, access list, access group, and policy map. So nothing new to explain. Same thing. Check the documentation. You will have it attached with this video. Okay viewers, now we will be moving forward to the last part of this video, which is step 5. Core switch 1A and core switch 2B initial setup and default routes towards the ASA. But before I go to the last part, there's one thing I really need to mention. Why we do need to set up the default routes. Why we are not using any dynamic routing protocol. It's a multi-context based topology. That means each firewall has 2 security contexts. Here, context A and context B. In this kind of architecture, there are some limitations. They do not support dynamic routing protocols. This is the major backwards. They do not support IPsec or SSL VPNs. They do not support multicast IP routing, and also lots of other limitations as well, like thread detection. So there is an scalability issue in active-active configurations. To simplify this, it is not easy to maintain. Yes, it is true that it's a complex architecture, not easy to maintain. Now to overcome this, we have cluster-based design. Now that would be a different lab, but I'm saying the limitations of ASA active-active failover, multi-context based architecture. Maybe in future we can create some content about firewall clustering. Okay, due to the huge limitation, we have chosen to proceed with the default routes. Okay, let's go to the configuration. This is super easy. Core switch 1, initial configuration, naming change, no IP daemon lookup to save time, line console 0, no logging sync. This is not mandatory, but we are saying that we do not need any further interference while we are typing. Ethernet 0/0, no switch port. We are taking the switch to the layer 3 mode by saying no switch port. That means it is now routable. Now you can assign the IPs. Without this command, you cannot assign IPs in a layer 2 switch. Same thing, 10.1, 10.11 here, and then 10.1, 10.33 here. Guys, we are using /29 mask, so it will be 248. 8 total host, 6 are usable. No shut, end, and then if you want, you can save it. Same configurations here, 15.11 here, 15.33 here. Okay, and then we can verify show interface brief, show IP route static, then it will show you the static route. And where is the default route or static route? I'm saying IP route 0.0.0, 0.0.0, 10.1, 10.9. It's a default route towards the context A here. I'm saying, hey, your default route is going via 0/1, via 0/0, via ETH 0/1, which is inside A, ETH1 here. ETH1 is ASS ETH1. Same thing here. I'm saying, hey, to the core switch B, your default route will be towards the ASA2's inside B, 15.1. So 0.0.0.0, 0.0.0.0, 15.1, 15.9. So guys, that would be all for this video. If you can follow along this documentation, inshallah, your lab should be up and running. But in case, if you have any questions, I'm there for you. Let me know by leaving question in the comments and I'll try to answer. Thank you.